Namaskar, welcome to the channel Anka Ananda Aharan, that is extracting happiness from the teaching learning process of mathematics. Today we are going to discuss some of the problems of problem set 2.4 of linear algebra and its application by Gilbert-Tram book. So the purpose of this video is to enable its viewers to study different aspects of four fundamental spaces of a matrix and their associated properties. So here this is our first question. Let us discuss. If M is equal to N, then the row space of A equals column space. Whether this statement is true or false. This statement is false. It is false. Why it is false? Because let A is equal to 1, 3, 0, 0. Naturally, what is the basis of row space? 1, 3. So, what is my row space? Row space is span of the vector 1, 3. That is equal to what? It is y is equal to 3x straight line on xy plane. What is the column space? Column space is, this is my column. So what is my column space? That is span of 1, 0. That is what? That is equal to x axis in the xy plane. So naturally, what we are getting, column space is not equal to row space, but here rows, number of rows is equal to number of columns, that is equal to 2. So here M is equal to N is equal to 2, but we got, but in spite of M is equal to N is equal to 2, but row space is not equal to column space of A. Hence this statement is, it is false. Next question is, if M is less than N, then the null space has a larger dimension than, the answer is left null space. Let us discuss. It is dimension of left null space. Okay, so let us verify that. M is less than N, that implies M minus R, where R is the rank of the matrix, is less than N minus R. That implies dimension of M minus R is dimension of left null space is less than dimension of null space. So this question's answer is understood to all. So hence there is, so dimension of null space is larger than the dimension of left null space. Next question is, find the dimension and construct a basis for the four subspaces associated with each of the matrices. So here U is the echelon form of A and it has a pivot, only one pivot, that is in the second column, first row. So rank of A is equal to rank of U, that is equal to R is equal to 1. In for both the matrices, M is equal to 2, N is equal to 4. So the dimension of and the formula is dimension of N of A transpose is equal to M minus R is equal to dimension of N of U transpose, that is equal to dimension of column space of A. In this case, now R is equal to this. Okay, so this is R is equal to this, so it is equal to 1, and R is equal to dimension of column space of A, that is dimension of row space of A, that is equal to dimension of column space of U, that is equal to dimension of row space of U, that is equal to, all are equal to 1. Okay, next is or two spaces, that is dimension of null space. Dimension of null space of A is equal to n minus r 4 minus 3 4 minus 1, that is equal to 3, is equal to dimension of null space of U. About the dimension, these are the concepts. Next, we know dimensions. Next, we know that dimensions of basis of n of A is equal to basis of n of U, and it is equal to how much, we find out. What about the equation? The equation is this is x1, x2, x3, x4. So x2 is pivot. So the relation is here, the relation is x1, x4. 0 into x1 plus 1 into x2 plus 4 into x3 plus 0 into x4 is equal to 0. That implies simply it is x2 plus 4x3 is equal to 0. This relation is with us. From this relation, we will find out here x1, x2, x3, x4. This is free, and this is free. Only variable pivot is x2. So as these are free variables, I will assign 1, 0, 0, 0, 1, 0, 0, 0, 1. So what I will get? Now substituting the value of x3 here, my x2 is 0 here, x2 is minus 4 here, and this is also 0 here. It is of no relation. X3 is 0 means it is 0. So what about my basis? So I got my 4 fundamental spaces basis. Basis of n of A is equal to basis of n of U is equal to 1, 0, 0, 0, 0 minus 4, 1, 0, 0, 0, 0, 1. Okay, left null space basis, we got it. Next we will go for Okay, so rest part of the question probably I have to do a little bit below. Before time I have not given any answers. Okay, okay, basis of null space is over. Now all other bases I will try to write here itself with small letters, because space, there is very less space. Optimally I will use this space. Okay, so observe here. What about basis of row space? This is first row, which is same as basis of row space of U. So basis of row space of A is equal to basis of row space of U, that is equal to the first row, that is 0 1 4 0. Similarly, basis of column space, what it will be? Here basis of C of A is equal to this column, that is 1 2, and basis of column space of U, C of U, it is this row, that is 1 0. So column space, row space, null space over. Now left null space we will study. So here let us observe. Let me write down the transpose of A and the transpose of U. So what about transpose of A? It is 0 0 1 2 4 0 8 0. It is A transpose. Similarly U transpose. So for A transpose, let me find out. So what is the relation? Now here I will multiply y1 y2 to get 0. But I will get how many zeros? 4 zeros. This I will get. So here this is the only equation which is representing all other equations in the matrix. So y1 plus 2y2 is equal to 0. That implies y1 is, so what will be my matrix? So y1 is pivot, so y2 is free, y2 I have given 1, so y1 is equal to -2. So basis of left null space of A is -2 1. And what about the U transpose? U transpose is 10140. Let me change the color so that it will be clearly visible. 0 1 4 0 0 0 0 0. This is our U transpose. So similar. So here what's the relation? Here y1 is equal to 0. This is the only relation I have. So y2 is a free variable. So what is the relation then? So anyhow y1 is 0, y2 is free variable, that's why it is 1. So basis of n of U transpose is nothing but it is 0 1. Okay, so with this let me first create space, then we will do, because creating space later is an issue. Once I am writing, then it is not moving, the icon is moving with all the equations. So sorry for your inconvenience that your time is consumed during my resetting, setting, all those things. So here find the dimension and a basis for the four fundamental spaces. Again it is very much similar to that. So here is a pivot, here is a pivot. So R is equal to 2, M is equal to 3, N is equal to 4. So dimension I will do for, okay, dimension of C of A is equal to dimension of C of A transpose is equal to dimension of C of U, that is column space, that is dimension of row space of U, all are rank, that is 2. Next, dimension of null space of A is equal to dimension of null space of U, that is equal to n minus r, that is 4 minus 2, that is equal to 2. Next is dimension of left null space of A, that is equal to dimension of left null space of U, that is equal to m minus r, that is 3 minus 2, that is 1. Regarding dimension it is not having any issue. Next is row space. C of A transpose basis, basis of row space of A is equal to basis of row space of U, that we will write here. We'll first find out, so what are the basis vectors? First row and second row constitute the basis vectors because they are having pivots in them. So it is 1 2 0 1. Second row is 0 1 1 0. Okay. Next is basis of column space of A. What is basis of C of A? First column of A and the second column of A. That is curly bracket 1 0 1 and 2 1 2. Okay, next part is basis of column space of U, that is equal to, the last row is 0 row there, so it is 1 0 0 2 1 0. Clearly we can see that column space of U and A are different, null space of U and A are different, and left null space and row space of U and A are same. Null space and row space for U and A are same. Left null space and column space for U and A are different. This we have observed. Basis of row space, basis of column. Now we'll find out the basis of column space. A column space सरेला null space service. No, it is only previous questions. So here now we'll go for the basis of null space. Now you create some space. So let us write down what is our vector. Now the matrix is U is equal to 1 2 0 1 0 1 double 2 0 1 2 0 1 0 double 1 0 0 0 0 0. This is my U. So here is a pivot, here is a pivot. That means the equations are x3 x2 plus x3 is equal to 0, x1 plus 2x2 plus x4 is equal to 0. Here the variables are x1, x2, x3, x4. Out of which this is pivot, this is pivot, this is free, this is free. So 1, 0, 0, 1. From x3 I get my x2 as minus 1, 0. And substituting the value of x2 and x4 here, what we get? It is 0, it is minus. So it is plus 2. It is 1, it is 0, so it is minus 1. So I got my basis of null space of U is same as, hence basis of n of A, null space of A, is equal to basis of null space of U, that is equal to 2 minus 1 1 0 minus 1 0 0 1. Okay, now let us write down A transpose and U transpose. It is 1 2 0 1 0 1 1 0 0 0 0 0. This is U transpose. What is A transpose? It is 1 2 0 1 0 1 1 0 1 2 0 1. Now this will be multiplied with, so A transpose Y is equal to 0 implies this is Y3, so Y1 equal to 0 2y1 plus y2 is equal to 0. And y2 is equal to 0. So here what we got, y2 0, y1 0, it is of no use. So just only free variables. So here this column contains pivot and this column contains pivot, because this is anyhow last column is 0 row, 0 column, so it has no pivot. So y3 is free. So what is it? So y1, y2, y3, it is free, it is 1. Already these three variables we have got. That is, here the vectors are. Oh, this we have done for, here I have not done for A, sorry. The calculations all we have done are for U. So it is U transpose Y gives me this. So what about the basis? So basis of N of U transpose is equal to 0, 0, 1, that is Z axis in the R cube. Now we'll find out for A transpose. Here what we will do? A transpose Y is equal to 0. So that means what equation? Y1 plus Y3 is equal to 0 and Y2 is equal to 0. From this equation and from this equation, these two are two linearly independent equations and this matrix has rank 2. Hence I have selected these two equations. So what we are getting? From the first equation it is 1 in, so 101 implies this, and second 010 it implies y2 is equal to 0. So here y1, y2, y3 it is free, it is 0, and here it is -1. So basis of N of A transpose, that is left null space of A, is -1, 0, 1. So four fundamental spaces basis we have obtained, but what we have observed again, we have observed that null space and row space of A and its echelon form are same, but column space and left null space of A and its echelon form are different. Next is describe four subspaces in three-dimensional space associated with. So it is, every component is having three components, so it's okay. So now first column is having 0 column, so it is it is a pivot, it is a pivot. So what is C of A? It is span of one zero 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 1 0. That means first two components can take any value. First two components can take any value means it is xy plane in R cube. Then span of row space, that is basis of row space means what? 0 1 0, first row and second row I am considering 0 0 1. That means Y component and Z component are free, X component is restricted to 0. So that what does it mean? This means it is YZ plane in R cube. Next is null space. So for null space, what are the equations? It is, let me write down the vector as x is equal to x1, x2, x3. So for null space, what I am getting? x1 is free, this is x1 is free, x2 pivot, x3 pivot, it is pivot, it is pivot, and the equations are x2 is equal to 0, x3 is equal to 0. Already the values are obtained, it is 0, it is 0, and it is arbitrary vector as per my choice I can take. So this is my null space. Huh. So what about the null space? So it is basis of null space is, so null space is equal to what? This is span of 1 0 0. What it is? It is x-axis in xy z plane or in R cube. In R cube. Next, left null space. Let us take A transpose. That is, what is A transpose? First row is 0 row, tapre 1 0 0 0 1 0 0 0 1 0. This is A transpose. So implies y1 is equal to 0, y2 is equal to 0, and y3 is free. So y1, y2, y3 which is free. So here 1, here 0, 0. So what I got? Null space of A is equal to span of 0 0 1. What it is? Z variable take any value, that means it is z axis in R cube. So null space, left null space, row space, column space, everything is explained. So with this, all the four fundamental spaces are discussed. Next question is, find a 1 by 1 matrix. देखिए कितनी जगह आज. Now there is no issue. Find a 1 by 3 matrix whose null space contains all vectors in R cube such that this equation satisfied, that is x1 plus 2x2 plus 4x3 is equal to 0. Find a 3 by 3 matrix with the same null space. So what it will be? 1, 2, 4. This is my A, which is 1 by 3. Matrix has null space equal to plane x1 plus 2x2 plus 4x3 is equal to 0. Because whenever I will multiply with x1, x2, x3, I'll get 0. That means all the vectors satisfying these conditions, a into x is equal to 0. So x belongs to null space of A. Now we have to find out B, which is 3 cross 3 with same null space. So what I will do, 3 cross 3 means it is, I'll write 1, 2, 4, Again another scalar multiplication of it, that is 2, 4, 8, another 3, 6, 12. So this matrix has null space is equal to x1, x2, x3 belongs to RQ such that x1 plus 2x2 plus 4x3 is equal to 0. So this part of the question is answered. Next part, it is why there is no matrix whose row space and null space contain this. We know row space is orthogonal to null space. They are orthogonal complement of each other. Hence, row space intersection null space is equal to 0, 0, 0. Only one vector. No other element is contained. So no non-zero vector belongs to both the spaces. That is, no non-zero vector is common to both the spaces. Therefore, 1, 1, 1 cannot be in both the spaces because it is a non-zero vector. Second part, suppose the only solution of Ax is equal to 0, that is m equations n unknowns, is 0 vector. What is the rank and why? Next is A is having m rows, n columns. So now Ax is equal to 0 if and only if B belongs to C of A. Ax is equal to 0 has solution if and only B belongs to C of A. It has solution implies B belongs to C of A. B belongs to C of A means it has solution. Now, if it has solution for if Ax is equal to B has solution for all B implies B belongs to C of A all for all B belonging to RQ. That is C of A is equal to whole R cube ne R to the power m. It is whole R to the power m. So C of A is equal to R to the power m, which implies dimension of left null space so first of all this implies dimension of C of A is equal to m that is equal to rank of A. So this is equal to this, that implies this is equal to M minus R, that is equal to M minus M, that is equal to 0. So any vector space is of dimension 0 implies it has only one vector in it, that is the origin vector, 0 vector of R to the power M. So this is my left null space. Now Y belongs to N of A transpose implies and implied by A transpose Y is equal to 0. That implies and implied by Y is equal to 0. Okay, so this part is over. Y. Columns of A are linearly independent. Everywhere I have written M, M, M. No. Correct. Linearly dependent. Here columns of A need not be linearly independent. They may be linearly dependent. Columns of A are linearly dependent. Maybe not. Yes, sure. If it's a pivot, naturally, yes. If M is linearly dependent, if N is greater than M. Okay. Suppose I have 4 columns and 3 rows. Then in that case, the columns are dependent. If number of columns is equal to number of components of B, that is number of equations, number of columns is equal to number of rows. In that case, it is linearly independent, or else it is linearly dependent. Yes, this is better. So conclusion is this: if M is less than N and independent if M is equal to N. Okay, number of rows equal to number of columns. Next question is this I already wrote down. Write the rank of A. Here it is not in echelon form, so this is equivalent to R3 minus 2R1 stored in R3. It gives me 1 0 0 3 0 0 0 0 0 0 0. So it is of rank 1. First column and first row represents the matrix. So here A is equal to 1 0 2, this is my U, and V transpose is 1 0 0 3. This is my V transpose. This is my V transpose. Okay, it's a little confusing however. So here this is my V transpose, this is my U. Okay, this is my A. Similarly, for the second matrix, what it will be? For the second matrix, what it will be? A is equal to, let us convert it into row reduced echelon form. What it is? It is, first of all, R2 minus 3R1 stored in R2. It is 2 minus 2, 6, sorry, 0, 0. Now, as I am interested to convert it into row reduced form, that is 1 minus 1, 0, 0. So this is my pivot and all the pivots are 1 and in the pivot column and rest all elements are 0. So now it is in row reduced form. So what I have done, R2 1 by 2 R1 stored in R1. So now what is my first vector? So first vector I can write it as 1 minus 1. So it is, I have two options. Either I will make my pivot in the first column, I will write this one. So here A is equal to 1 3, here 2 minus 2. Either I can write like this or I can write 2 6 1 minus 1. Anyhow, any format will give me my A in required form. Okay, so this question is over. Find the left inverse, the right inverse whenever it exists. So here, if A is a matrix of rank R, then A transpose has rank R. So here one can observe that A and M are transpose of each other. So what we are getting? First we will find out for A, then everything we will conclude about M. So first of all, A is of rank of A is equal to 2 because it is in echelon form and there are two pivots. So which is equal to number of rows, which implies right inverse exists. And the formula for right inverse is A transpose whole inverse A transpose. Okay, so let us find out first A transpose. That is equal to 1 1 0 0 1 1 1 1 0 0 1 1. It is 2 1 1 2. Then its inverse is A transpose. This is equal to 1 by 3 2 2 minus 1 minus 1. I have applied the formula for inverse. Okay, I hope all of you know it, that A, B, C, D inverse is 1 by AD minus BC, DA minus B minus C. This. Okay, So using that formula I got my A transpose this. Now what about its inverse? Already I have obtained. So what is my R then? Right inverse Ri is equal to A transpose A transpose whole inverse. How much it is? It is 110,011 whole into 1 by 3. I have taken outside this 1 by 3. Then 2 minus 1 minus 1 2. That is equal to 1 by 3 multiplied with 1. It is 2. It is minus 1. It is 2 minus 1. It is 1. It is minus 1 plus 2. It is again 1. It is 0 minus 1. It is minus 1 plus 2. So this is the right inverse. Therefore, right inverse of A is equal to 2 by 3 minus 1 by 3, 1 by 3, 1 by 3, minus 1 by 3, 2 by 3. Similarly, now we will calculate for left inverse of M. Observe here, M is a matrix having 2 columns and 3 rows and rank is 2. As its rank is 2, that means rank is equal to number of columns, hence its left inverse exists, and left inverse formula is देखिए अगर स्पेस अच्छी नहीं. Now there will not be any issue. What is left inverse? Left inverse formula is M transpose M whole inverse M transpose. Okay, let me write down that value. It is M transpose. Here M is a 2 column vector, so its transpose is 1 1 0 0 1 1 1 1 0 0 1 1. It's a whole inverse M transpose. It is 1 1 0 0 1 1. Okay, so now what it is? This matrix already we have obtained in the previous value, that is, and its inverse is 1 by 3, 2 minus 1 minus 1, 2. This into 1 1 0 0 1 1. Let us calculate. Its value is 2 into 1, it is 2, 2 into 2 minus 1, it is 1, 0 minus 1, it is minus 1, minus 1, it is minus 1, 2, plus 1, it is 0, 2, whole by 3. So what we got? Hence, the left inverse is, so left inverse of M is nothing but 2 by 3, 1 by 3, minus 1 by 3, minus 1 by 3, 1 by 3, 2 by 3. If any confusion is there, one may multiply with it M from the left side to get the, so this matrix should be multiplied to M with from the left hand side to get the identity matrix. Okay. Okay, next is T is equal to A, B, A. So what it is giving? T is equal to A, B, 0, A. So here, if A is equal to 0, then rank of T is equal to 1, which is not equal to number of rows, neither not equal to number of columns. So left inverse and right inverse both do not exist. So but for if A is not equal to 0, then rank of T is equal to 2 is equal to M is equal to N, which implies left inverse is equal to right inverse is equal to inverse. Exist. So all the left inverse, right inverse and inverse, both all the three exist and their values are same. So directly I'll find out the T inverse, which is my left inverse, which is my right inverse. So it is 1 by A square. Position of A changed. It is minus B, it is 0. So this is my left inverse. So that is means, let us take this A square inside. It is 1 by A minus B by A, 0, 1 by A. This is my left inverse of T, right inverse of T, that is inverse of T. Now here, find a basis for each of the four subspaces. Like this we have done several problems. Let me see how many questions are left. Several questions are left. Okay, just I will give some hint here because already we have done such type of problems. And we will. So here it is the echelon form of the given matrix. So first pivot, second pivot. So here basis of row space is equal to 0, 1, 2, 3, 4 and 0 second row, that is 0, 1, 2, 4, 6. This is basis of row space. And basis of column space, what are the pivot columns? That is first and third, sorry, second and fourth. That is 1, 1, 0, comma 3, 4, 1. Okay, basis of column space is also over. Now what about the null space and left null space? Observe here this column. Observe. Now when I will write A transpose, how it will be? A transpose means it is 1, sorry, 0, 0, 0. I'm not interested in all those. Just I will take these two rows. From there I will go for my conclusion. So how much it is? So when I am writing the transpose 1, 1, 0, 2, 2, 0, 3, 4, 1, 4, 6, 2. So this is how many, where are the pivots? Two pivots are there means three free variables are there in case of column, and here it is y1, y2, y3 is equal to 0. How many zeros? 5 zeros. I want to find out y1, y2. So from the second equation what I got? y1 plus y2 is equal to 0. And from the third equation it is 3y1 plus 4y2 plus y3 is equal to 0. Now here y1, y2, y3 are three variables. So here pivot, this is free. Okay. So because the first components are having this, so third component is free. Third column vector free. So it is how much we are getting? It is 1. Now it is free. So here 3 times of it implies y2. Subtract 3 times of it. So how much it is? Y1 is eliminated. So it is 3 times of this is subtracted from this equation. I am getting y1 eliminated, y2 plus y3 is equal to 0. So y2 is equal to minus 1 and here it is plus 1. So the basis, what I have done, I hope all of you have understood. The equations which represent the all the equations, I have taken those considerable equations because observe here, this is a scalar multiple of this, and third equation is a scalar multiple of second equation. First equation anyhow it is zero equation. So second and fourth equation represents all the equations of the left null space. So I have got my left null space basis vector. I have considered the second and fourth equation by solving which, and here my y3 is free variable. So that's why what I have done, I have taken this equation. How much I am getting? Basis of left null space is 1 minus 1 1. Okay, basis of null space is 9. Okay, so now let me write down the null space equations from the echelon form. This is 0, 1, 2, 3, 4, 0, 0, 0, 1, 2, 0, 0, 0, 0, 0. This into x1, x2, x3, x4, x5 is equal to 0, 0, 0. So that implies there are two equations, that is x4 plus x5, 2x5 is equal to 0. Another equation is x2 plus 2x3 plus 3x4 plus 4x5 is equal to 0. Now from these two equations, let me write down x1, x2, x3, x4, x5. So second, this is x2 and x4 are pivots. So it is pivot, it is pivot. So free, 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 1, 0, 1, 0, 1, 0, 0, 0, 1. I got it. Now from x5, so twice this, so it is minus 2, it is 0. Here this free variable I have wrongly assigned. One word like this. So no free variable can be assigned twice 1. 1 0 0. So this is 0. This is minus 2. Okay. So now substituting these values, x2, x3, sorry, x3, x4, x5, we get x2 is equal to, here it is 0, here it is minus 2, okay, x4 so minus 6, it is plus 4, so plus minus 2, it is plus 2. Oh, divided by 2. No, ठीक है. So this is 0, this is minus 6, this is plus 4, so it is minus 2, 10 to that side. So these are the vectors. Finally, I got my null space basis vectors. What are they? So basis of n of a 1 0 0 0 0 certainly. Then it is 0 minus 2 1 double 0. Then it is 0 2 0 minus 2 1. So with this we have done the basis for all the 4 fundamental spaces. Next we will go to the next question. Construct a matrix with the required property or explain why you cannot. Now A is just simply these columns. It is my A. Naturally columns of A are these two, that means the column space of A contains these two vectors. So first condition satisfied. Now row space contains 1 2 and 2 4, that means my row space C of A transpose, that is row space, is a subset of R square. But there are two linearly independent vectors. So here 1 2 is not a scalar multiple of 2 5. So these are two vectors which are linearly independent, and these two vectors are taken from R square, and it is of dimension 2. R square is a two-dimensional space, and this collection is a collection of two linearly independent vectors. Hence they span the whole R square. That is C of A transpose, a row space of the given matrix, is the whole R square. That means any two. So here what happens? Observe, this is a submatrix of A. That means 1 0 0 1. It is a basis for R square. So these two rows span whole R square. So 1 0 span of 1 0 0 1 is equal to whole R square, which is equal to my span of 1 2 2 5. Hence my whole R square. So that's why row space of these two vectors, row space, the vector space spanned by these two vectors is same as the row space of A. Hence, the first part of the question is over. First A bit is over. It satisfies both the claims. Next is B. Column space having basis this and null space having basis this. Now column space is having one vector basis. Then dimension of C of A is equal to 1, and dimension of null space is equal to 1. But we know, and to have three components, if 3 2 1, this vector belongs to n of A, implies A has 3 columns, but and we know and dimension of column space of A plus dimension of null space of A is equal to 1 plus 1 is equal to 2, but originally it should be same as number of columns of A, which is equal to 3. So here this value left hand side is 2, right hand side is 3, so 2 is not equal to 3, hence such a matrix cannot be constructed. If I have 3 components in my null space vector, naturally I have 3 columns in my matrix, and number of columns is equal to dimension of column space plus dimension of null space. But here it is having one vector in its basis, it is having one vector in its basis, so they are of dimension 1 1. So such a space cannot be constructed, such a matrix cannot be constructed. Now dimension of null space is equal to 1 plus dimension of left null space. Yes, it can be constructed, and just what we will do, we will increase the number of column by 1. Suppose it is 1 2 3 0 1 2. This is my matrix A. So clearly we are observing it has 2 pivots. So rank is equal to 2. It is rank of A, which is equal to 2. That implies dimension of null, it is 2 rows 3 columns. So dimension of null space of A is equal to 3 minus 2, that is 1, and dimension of left null space of A is equal to 2 minus 2, that is 0, that is 1 plus. So it satisfies that the condition that dimension of null space of A is equal to 1 plus dimension of null space, left null space of A. So such a matrix can be constructed, and we have shown it. Next part of the question is what is the D bit? D tessel library. No, left null space contains this and row space contains this. Okay. My matrix has row space 3 and 1. Suppose I have a matrix with row space 3 1. That means, let me write down it as, and left null space is 1 3. So dimension of both the number of rows is equal to, so it is a 2 cross 2 matrix. Now this, it is my matrix, this is my A. So what is A transpose? A transpose is 3 C1 1 C2. Now A transpose into my given vector, that is 3 1 C1 C2 into 1 3 gives me 0 0. What is the relation then? This implies 3 plus 3C1 is equal to 0. So what about my C1? That implies C1 is equal to minus 1. Similarly, second equation gives me 1 plus 3C2 is equal to 0. That implies C2 is equal to minus 1 by 3. So my equation, my matrix is A is equal to 3, 1, minus 1, minus 1 by 3. It has 3, 1 as the row space basis and 1, 3 as its a null space basis. Okay, next part, last part. Row space is equal to column space, but null space is not equal to left null space. E. Row space is equal to column space. This implies M is equal to N. Okay? Row space is equal to column space, number of rows is equal to number of columns. That implies M minus R is equal to N minus R. Now, null space, left null space is a subset of R to the power N and which is equal to here R to the power N, and left null space is originally a subspace of R to the power M, but as M is equal to N, so in this case it is R to the power N. That means any M minus R number of linearly independent vectors outside my C of A, not contained, outside means not contained in C of A, form a basis for n of A transpose, and any n minus R linearly independent vectors from complement of row space of A span null space of A. As my M and N are same and row space and column space are same, therefore the same set of vectors span both the spaces N of A and N of A transpose, which implies N of A equal to N of A transpose. But लिख दो छड़ा, but given N of A is not equal to N of A transpose. Hence, such a matrix cannot be constructed. Okay. Next, construct a matrix with basis this. basis for row space as well as column space. Here, as it is a matrix having same basis for row space and column space, that means if I will take a symmetric matrix, then I will get its row space is equal to column space. So what I will do, I will write a matrix using these vectors as symmetric matrix, that is 1 0 1 1 2 0. To construct symmetric, here I will take 2, here I will take 0. So observe here, this is the column 101, this is the column 120. So these are there in the column space. And the first row is row space vector and third row is row space vector. Now here I want what should be my value. The value will be minus 4. How to know? Suppose I have written here C. Instead of minus 4, let us assume that it is written here C. Then what will be the pivot case? Row reduced echelon form. Let us find out. So here what it is. This is, I want that it is a basis, means the dimension of dimension of row space and dimension of column space must be 2. That means this vector should be linearly dependent on these two rows. Now let us write down. So here, let us find out its echelon form. It is how much? It is R3 minus R1 stored in R3. So it is 1 0 1 0 minus 4 2. It is 0 2 0. No, second time. 0 2 minus 1, sorry, last row is minus 1 is subtracted now, so it is minus 1. So observe here, suppose I might be having here C, so this columns by minus 2 times I have this vector, so naturally I should put here 4 so that it will be singular. To make it singular, I have to substitute here 4. That is minus 2 times this component. So now what I got here? It is, I want to make the singular form now. So it is how much? R3 plus half R2 stored in R3. How much it is? 1 0 1 0 minus 2, 0 minus 4 2. It is 0 0 0. So it is of rank 2. Hence these two vectors form the row space and column space. Okay, so this is a matrix A whose row space and column space are same. Why it is so? Because it is a symmetric matrix and these two vectors span it. Why it is so? Because they are linearly independent and rank of the matrix is 2. That means these two rows span its row space and these two columns span its column space. Why this can't be basis of row space and null space? As row space is orthogonal complement of null space, no non-zero vector can be common to both these spaces. So these two vectors cannot be common to this space as well as this space. Only vector common to these two spaces is the zero vector. Hence, no non-zero vector can be common, so that's why it cannot span the row space and null space. So with this, our today's video is over. Thank you for your patient listening and sorry for the inconvenience caused due to technical difficulty.